and welcome to Mateo's Math. Today we're going to be looking at the mean value theorem and some examples of it to show you what it is. Alright, now our first problem I'm going to write on the board is we are going to find all of the numbers of C, that's a constant in the mean value theorem, that satisfy the mean value theorem. So let's do 4x cubed minus 8x squared plus 7x (2, 5), which means we're going from 2 to 5. It has to be in the interval 2 to 5. Now, we're given that the mean value theorem is f of x equals f of b minus f of a all over b minus a. That is the mean value theorem by definition. Now we need to plug everything in, because over here we can take the derivative of our given function and plug it in as f prime of x, right? So that would be 12x squared minus 16x plus 7 equals f of b. B is 5 because it's our second value in the interval, right? And then, so we plug that in, 4 times 5 cubed. Well, let's just write out what it would eventually be. That would be 333 minus f of a, which is 12, plugging in 2 to the equation. And then lastly, over 5 minus 2, because over b minus a. Now we got this, and now we can solve. But first of all, when we take the derivative, we replace all the x's with c's. So watch this. Just simple 12c squared minus 16c instead of 12x squared minus 16x. Alright, now we can solve. We would get, once we evaluate this, would be 12c squared and 16c plus 100. No, I think it's minus 100. Just simply moving the right side over. Yeah, it's minus 100. Equals 0. Now we can erase the top, use the quadratic equation to solve it. Hopefully you haven't forgotten it, because we're using it right here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. There's the quadratic formula, and now we can plug everything in. Negative b is 16 plus or minus the square root 16 squared minus 4 times 12 times negative 100 all over 2 times 12. This would be equal to about 2 plus or minus square root of 79 all over 3. Now let me split this up into two of them. So the first one's going to be 2 plus, just simply splitting up the plus or minus, alright? 2 minus the square root of 79 all over 3. Still be on the board, you can see it. Alright, now this one's approximately equal to 2.6, I believe. And the second one is approximately negative 2.3. This is 3.6 up here. And as you can see, let's see which one's in the range. As we can see, The second one is definitely not in the range. It's negative. Do we have any negative values in the range? If you ask me, or if I ask you, we would both definitely say no. So this one is the only value of c that satisfies the equation. The 2 plus the square root of 76 all over 3. Not the 2 minus 76 all over 3. Because that's negative. The first one is positive 3.6. Now let's move on to our second example. I'll write it on the board. Has an exponential equation. So we'll also be employing here 8x plus e to the negative 3x on negative 2 to 3. Now we're going to solve this. So remember, right? So f prime of x, taking the derivative 8 plus, remember, chain rule here, so it's e to the negative 3x, right? Because the expression times the derivative of the inside, which is negative 3. Got that? Chain rule. Chain rule for exponential functions. All right. Now this second part should be easy. I'm just going to write it on the board. We're not going to calculate it because we don't have the time to do that. So that would be about 40 plus e to the negative 9 plus e to the 6 minus e to the 6 all over 3 minus negative 2 would be 5. So I've simplified it also. Now we can move everything over. I'm going to convert it into a decimal so you don't get lost here. Because decimals, I just think they're much easier to work with than giant fractions. Do you think that? Well, yeah. Because, well, first let's multiply each side by negative. So negative would make the 8 negative and e positive. Alright, so now we have enough space to move this 8 over. So watch. Well, put the minus out there and then it becomes plus with the minus, right? E to the negative 3x, well actually 3 of it. 3 of equals, we can move the 8 over, so it'll be 8. Now this has a minus sign on it, so it'll be 8 minus expression. I'm just going to call that thing expression for now until we're done evaluating it. So e to the negative 3, actually this is supposed to be c. Remember, we convert all the x's into c as soon as we take the derivative, right? And then dividing the other side by 3, I'm going to convert this into a 20-something decimal right here. So stay in it. We're still dividing this whole side by 3, so divide it by 3. And then we're going to get this decimal 26.895. If you want some more decimals, 2447. Alright. Now you know what to do. Yes, exactly. Take the natural logarithm of both sides to get rid of that. To get negative 3c. The natural logarithm of this number 26.8952447 is, let's see here, would be 3.2919 for some more decimal places, 495. Alright, now we divide that by -3, divide both sides by -3, or move the -3 over, whichever you're used to, and we will get C. I'm writing it up here. Let's write it in green so we can know it's our answer. C is equal to, let's see, after we divide that by -3, it'll become -1.097. And that's all the decimal places we need if we want to do it to the thousandths. And of course, if we had taken this expression and manipulated it, we would have gotten a huge expression that would be really hard to tell if it's in this interval. But -1.097 is in the interval. It's more than -2 and less than 3. Alright. Now, thank you for watching this video. Please subscribe to Mateo's Math down below. And see you in the next video for some practice problems in the mean value theorem where you can work it out yourselves.